Welcome everybody. So this is just a quick experimentation between creating this pop through fluid solver and rendering it as a strain in REDSHIFT. So as you can see, I have two kind of animation. The first one is strains, and the one beside it, the blue one, is the particles. If I can zoom in, as you can see, this is a flip book. So this is the strains or the lines. Okay, so we'll just walk you through how we went through this project. Let me just stop this one, disconnect. Okay, so let me go to the first frame. Here I have three lights just surrounding the object, and I started with a sphere. So this is the sphere, and what I did, I went and created Autodoc network, and I didn't use the particles. I went and I used the viscosity tab, the viscous fluid. I use lava from object, so I can extract the temperature. So here, let me just go up with the resolution so we can see. So this is the effect. Just give it a second. So I'll just disable all of this, and we can go through it one by one. Okay, so initially we have this flip object, and this is a flip solver. So we didn't use the pop network because I want to take advantage of the viscosity fluid and temperature also that being generated. As you can see here, we add viscosity attribute and we add here temperature attribute, and we are pointing to that object. So if I put the gravity, it just simply fall down. And here if I close, so it's just a fluid, as you can see. Okay, so no need for gravity. So first thing I did, I added a force. This force just to give me a little bit of a sine wave, so it will go up and down, if you can visualize it. So the force will point in y positive, then y negative, positive and negative, up and down. Okay. Also I make it spin through the axis. The axis will make it 1, so it's in the y, and it's spinning around the center where is the subject. Okay, and this is the force. This one, the force parameter, is the length of the force multiplied by the cross product between the center and the axis. So this is how it will look. To have some abstract visualization, which is nice to look at. Then I added the pop interact, and the pop interact will affect between the particles, as you can see in the thumbnail. So either they will come together, join together, or they will be separated from each other when they are coming closer to each other. So, and I use the same sine f multiplied by 15 for the position force, and the velocity also going in positive and negative, positive and negative. so they will rebel and join together, rebel and join together, as you can see in this trail. So I can have these, and then I added another local force, pop local force. Also I use the same function, just copy and paste, and this is how it will look. Just experimenting with pop forces here. You can come up with a lot of variety. See how different. So let me just fix this one, make it open, and go to my camera. This is how it looks now. See this tentacle, cool. After that I added the pop axis force, and this will make it spin around it, or it can be lifted. But this is how it looks. Now it will start to spin around this sphere, orbiting. So I have more extracted wave or abstract wave, and here I just make the orbit speed with the same function, so it's orbit like this and rotate with the other hand. So give it this random movement, so the tentacle or this arm can be like wavy a little bit, as you can see. Then of course all particle better to have a drag, so it will not fly all the way out away, so they will be kept together, and I kept it at the default of 1. Let's make it 0.5, so they will spread more out away. See that tentacle. Okay, after that I want to enforce the confinement vortex, so I added this one from the microsolver. Same thing, I give it a boost also for the vortex, a little bit like 2. Let's make it 1. This is how it looks now. A lot of variety you can play with. It will give you nice shapes, and of course when you bump up the resolution, more particle, it will look even nicer. Gas from temperature, also gas temperature update, so it will change the cooling rate of the temperature. It will become more red, and it will be more viscous and more rigid and solid. And I used this temperature in the coloring also. So it will look nicer than the one I created. Here in the flip solver, in the particle motion behavior, I add ID attribute, I added a droplet and vorticity. In the volume, nothing changed here, only I added a little bit of viscosity, very low number, and this is what we come up with. Okay, after that from the droplet tool we imported it. So as you can see, this is from the shelf tool to have the fluid surface. So we import and we cache it, and this is the cache we come up with. So let me just bypass it so we can have the same one we got before. Okay, here let's have a look at the surface. If we move to surface it, very nice. Give it some smoothing. Okay, but I didn't service it. I wanted to use the particles. So here I have the particles. I just rotate it, but I will not rotate it here. Here I created a trail sub. So the trail will create more particles, as you can see, because we have the ID. Where is it? Here. So it's creating this particle and copying it, but it will have the same ID that we can use it to create a line. So I added the add node, polygon, by group, by attribute, and I use the ID. So this will create the line. Okay, let's go here. After that I use the same color. That's a color ramp from attribute, and here I use the temperature, this viscosity, for instance, vorticity, position, velocity. What else we have? Dead, no. Droplet. This one look nice also. Droplet, force. So you stick with the temperature, and I use the, which one I use? Black body, and it is out. On the other hand, I did another copy, but for this one we imported. I remove, attribute, delete. What did I delete here? Nothing. Transform, I will stop it. I make a little bit point jitter, so the points will, when they render, they don't just sit on top of the lines. Just move them aside a little bit. I make a trail, so I trail the same node I used there, but I didn't add sub, so it's only, as you can see, points. And the points here according to the temperature, according to the temperature. Let's go up. Let's play with it a little bit more. Let's go with velocity V. Something like that. Then if I add it, it will be on top of it. See, maybe you can choose another color. Let's go with something vivid. Magma, no, not this one here. Twilight. Okay, now in the material, this is the output, this is the material. Here what I did, because if you go here, we have the CD attribute that is the color of the bonds. I'm going to use it in REDSHIFT material. So right click, tool, REDSHIFT point attribute, this one, and I add the CD. If I add, choose something else, What do we have here? V. Let's use V, the velocity. Let's make the velocity affect what we can affect here: metalnation, refraction, back face. Yeah, because in the color I'm affecting the color, also the translucency and backlighting. I'm gonna give it very low number, not reflection. Let's affect the sheen. Sheen color. No, sheen weight. Let's give it a go. Let's see and play with it. Okay. And I added in the render, I added the material. Okay. But in the render object here, for the lines, REDSHIFT strands, I enable it and I use strips. Cylinder can work, but I use strips, and I make the global scale very low, 0.02. For the particle, in REDSHIFT tab, particle, I am rendering it and I give it very small p scale. Let's go out. This is the rope. Let's take a frame and just reload. Very nice. Let's play a little bit with the coloring. Here, color. Let's play with different type. White water. White to red. This one look nice also. And in the material, if we disable this, I'll go up and I disable this first color. So this one look very nice. Let me stop and go to another frame. Let's see the camera and render it now. Very cool. Maybe we can add also motion blur here, denoising motion blur. Let's add it, because what I did also, just to show you the camera, I activated the depth of field. If I choose the camera, let's move away, right click on the camera, and I have the frostum handle and the frostum, the focus. So this focusing with shallow depth of field. Let's make it even smaller. Okay, let's point to the camera, and here it's activated. Let's have a look. And this is with motion blur. Okay, I'll stop the motion blur for now, and just try to zoom in with the camera. Let's go somewhere here. Let's have a look now. Because we need to fix where is the camera? Control G. There. See where is the depth of field now. It did move, so let's move it back. And increase it. Okay, now render again. And let's have a look, like a close-up. I'll stop it as I'll disable the depth of field for now. In the advance, where is the depth of field? I forget. Depth of field here, REDSHIFT, remove. Let's zoom out a little bit. Oh, sorry, I should choose a camera. Fix it. Let's go here. Something like this. I want to show up these two lines. Okay. Render again. So this is the points. Maybe we can make them smaller. So, and just make it 0.01. And zoom out. Yeah, this is the one. Let it render for a while. Look like fur. We can spend hours just playing with it. What if this one, I make it rotate like 90 degree? What other effect we will have? Let's reload it. It's so fun to play with. So this is just a quick experimentation and walk through how to mix things up and rendering it finally with REDSHIFT. Thank you for watching and have a nice day.